ChatGPT, we score each category. There's 106, and for each category, there's 8, actually just 7 to score. There are 7 cell types, so it's a mast cell, the skin, the liver, the pancreas, the white blood cells, all that, the brain, and the 8th is actually just the average of the 7. I have that added because we might not know what the pattern is, or it might be something else, but hopefully we kind of have to make that decision. I think the 7 cell types would be where most of the proteins are produced every day, very active, but you might want to also do a protein sequence for some other cell types, and so that's why there's like number 8. But anyway, so all that scoring, it does have some reason behind that. So if you see, I think the best way to because there's so many scores there, but most are actually just 1. I think the highest is 1.5 and the lowest is 0.4, I think, and but most are kind of around the 1 area. It means that it's kind of neutral. And so if you see like extreme values, it really means that it could be very compatible or incompatible at all. So you can ask ChatGPT why that is the case. So if it's just around 1, it could be just not much, but if it's like 0.4, 0.8, you can ask why it's incompatible. So ChatGPT can answer that question. And so after all that scoring, there's another dashboard that will collect all that information, and then it's by categories, by amino acids. So some each amino acids may be a member of several categories. So really the first group has more categories per amino acids. It could be over 30. And then the second group, the functions, it's much less. Some only has 1 or 5. So it is a function, but it does have, each function also has categories. And then if you're like, okay, but how did you actually get those numbers? There's multiplier, which we will use to multiply. As a multiplier, you can examine each, so by amino acids. So if it is by amino acids, then it's mostly because the amino acid is present there. So you see what amino acids you select, it will also have the most count in that next dashboard, and then it will tell you which categories it is and what was the scoring, and you will see you're able to match it. So that dashboard will automatically, it uses UDF. I'll show you 2 UDF. The first one will gather all that, because I used that for something else too, the text join F multiple, and so it returns all the, but it actually is flexible. So that one is used to return the categories, and then but this will return the values. And then I have another UDF that, because it's in a string form, that will actually average out the string numbers. So that is how the average is calculated. And then when you actually select a certain amino acid or a certain function, it will also show you the actual calculations, because it will return all the scores for each category, and then it is being averaged, and then at the bottom it will show you that yes, it matches the UDF calculation. So once we have that, there is another dashboard in another sheet in MDB main dashboard, and now for now it's just taking what was selected in the other dashboard, in my other presentation, whatever you select there, it will be the one that will be used, but it still is in progress, and we can also use protein sequence from actual database. So right now I just completed like the scoring system. That's kind of the goal for now. And so now that we know where the multiplier is used, so given a given cell type, like the brain, each amino acid has its own multiplier, like which is most compatible for a brain cell, and then it will be multiplied to the count, to how many amino acids are in this protein sequence, and then that's when you get the number, a new value, which is still kind of similar to the value, 0 to 2. That's the expected range, with 1 being neutral. And so in this example is 1.18, which is moderately compatible with the brain cell. And so that's for the first group by amino acids, and then the second grouping will be by functions. And now, I made an error because I divided the same way as the first group, which is by length, sequence length, but later on I realized my mistake, and then I divided it by its own column, by how many actual amino acids in that column was used for the scoring. So now we have a more normalized score that is the same way, the same thing is between 0 to 2, and most are actually within like 1, 1.13, 1.20, 1.30. I think the highest is 1.30. So those two were the highest score for the sequence pattern, and the overall score we can now it is now also normalized, and it is 1.17, which is very close to the 1.18 for the amino acids. So by functions, it is indeed compatible. And so, if you really thought about it, most will probably, this could be used as like a preliminary or like a quick way to assess the protein sequence, or like, okay, given the cell type, it is compatible, but there's more to analyze. This is more like, okay, let's just do a quick check that these amino acids should be here, that like in the brain cells, that we shouldn't have, for example, maybe not a lot of basic or acids, something like that. So if you like, it can at least you can catch like the basic mistakes of like, oh, you shouldn't have these, or maybe even for muscle types, like there are certain amino acids that really lower the score, lower the compatibility. So I kind of think of that as like a quick check for the protein sequence. Like even you just plug in your sequence, and then you get like a quick compatible check. And there's more quick checks that we can do. Like I still have the one I introduced, the pattern checker, so there could be more dashboards, and before you delve into like maybe simulating like interactions, environment, something like that. But at least you can kind of do a quick simulation to like and do all these preliminary checks before you do even more or further analysis.